At -89.2 degrees Celsius, a thermometer at Vostok Station once measured the coldest temperature ever recorded on Earth. At that point, steel turns brittle, breath freezes as it leaves your lungs, and exposed skin can be damaged in less than a minute. It is a level of cold almost no human being will ever feel. Now let the camera rise above that lonely station until Vostok shrinks to a dot. Around it stretches Antarctica, about 14 million square kilometers of ice, bigger than Europe. More than 98% of that surface is buried, in places under more than 3 kilometers of ice. Larger than Europe, Australia, and India combined, and yet, for most of human history, it might as well not have existed at all. For thousands of years, people drew maps of the world without it. They mapped the Mediterranean, Indian Ocean, Africa, and Asia. But at the very bottom of those maps, the page simply stopped. There was ocean, guesswork, and sometimes a vague southern land drawn more from imagination than observation. The place we now call Antarctica was a blank space, literally, on most of our oldest surviving charts. Today, if you stand on a cliff of coastal ice, the scale of that blank becomes real. The nearest permanent towns are thousands of kilometers away. The Southern Ocean wraps around the continent in a ring more than 20,000 kilometers long. Waves can climb higher than a two-story house, and winds often reach more than 100 kilometers per hour. For early sailors in wooden ships, this region wasn't just remote. It was a barrier that said, very clearly, turn back. Because of that, only a tiny fraction of Antarctica has felt a human footprint. Even now, with planes, icebreakers, and satellite navigation, only a few thousand people live on research stations in summer, and closer to 1,000 stay through the winter. Spread over 14 million square kilometers, the average personal space is the size of a small country. Large parts of the interior have never been visited on foot. So how do we know what's there? Over the last few decades, scientists have used tools that can see through a kilometer of solid ice. Satellites circle overhead and track tiny changes in gravity. Planes drag radar instruments through the sky, sending radio waves down through more than a kilometer of ice and timing how long they take to bounce back. From this, we can build a picture of the hidden bedrock, of valleys and mountain ranges that never see the sun. One of those ranges, the Gamburtsev Mountains, rises to heights of around 3,000 meters, yet lies completely buried beneath the ice sheet. Pull back in your mind and picture the whole continent as a frozen shield rising more than 2 kilometers above sea level in the center. The ice holds about 26.5 million cubic kilometers of frozen water, enough to raise global sea levels by nearly 60 meters if it all melted. Quiet, distant, seemingly unchanging, Antarctica looks like the last place you'd expect to find controversy. But when we compare this modern, data-rich image with some early maps, we start to see cracks in the foundation of the story we were taught in school. For a long time, the official line was simple. Antarctica was first sighted in the early 1800s, around 1820, by European expeditions pushing farther south than anyone had gone before. Before that, there was no real knowledge of the southern continent, only vague ideas. And for the most part, that story holds up. There is no clear, undisputed record of anyone walking on the Antarctic mainland before the 19th century. The environment is too extreme, the distance too great, the reward too small. And yet, scattered through a few Renaissance and early modern maps, we see something odd. At the very bottom of the world, beyond any land those mapmakers should have known, appear coastlines, bays, and long stretches of what looks like a southern landmass. Some of these are wildly inaccurate. Some are obvious guesswork, but a few shapes seem, at a glance, to echo parts of the real Antarctic coastline we know today. They don't fit the narrative of total ignorance before the 1800s, and so they are often quietly dismissed by scholars as coincidence, distortion, or creative decoration. That may be all they are. Human brains are very good at pattern matching. We can see familiar outlines in clouds, stains, and satellite images. Given enough old maps with random scribbles at the bottom, some of them will line up vaguely with the real South Pole by sheer accident. But as we'll see, there are details that make some researchers pause and say this challenges accepted history. Details that at the very least raise questions about how information travels across centuries and how fragments of knowledge can survive even when the cultures that first found them are gone. For now, it's enough to hold two images in your mind. One is the modern Antarctica, colder than almost anywhere else, shaped by winds, ice, and darkness. The other is the historical Antarctica, the blank lower edge of the map, where imagination and fear filled in what observation could not reach. Between those two images lies the mystery we're here to explore. Welcome to the Nocturne History, where mystery and sleep walk side by side. This is Mystery History for Sleep, a slow descent through maps that shouldn't exist, coastlines that shouldn't be known, and ice that holds secrets older than civilization. Because if even one of these Renaissance maps shows Antarctica as it truly was beneath the ice, then everything we think we know about ancient navigation needs a reboot. Now, we narrow our focus from an entire continent to a single piece of tanned animal skin, just 85 by 60 centimeters across, covered in careful ink lines drawn more than 500 years ago. On it, some people believe, is a hint that someone, somewhere, knew more about the far south than they should have. Whether you're wide awake or already drifting, let that thought sit quietly in the back of your mind, like a coastline half seen through fog, letting your mind drift toward that curious map. On a fragment of gazelle skin just 85 by 60 centimeters, drawn in 1513, there is a coastline that some people say looks like an ice-free Antarctica. It sits at the very bottom of a world map almost 300 years before anyone officially saw the Antarctic mainland. No satellites, no steamships, just ink, guesswork, and whatever older charts an Ottoman admiral could gather. Somehow, out of that, a southern land appears where none is supposed to be. Imagine the fragment under glass. Most of the original map is missing. We only have a corner. On it, the Atlantic Ocean is clear enough. Parts of Europe and Africa, a long curve that matches South America, islands scattered like stepping stones. Then your eye reaches the lower edge. Instead of empty sea, a band of land runs along the base with bays, islands, and little mountain symbols. It isn't labeled Antarctica. It's simply there. This is the Piri Reis map, named after the admiral who drew it. Piri Reis was not a purely academic figure. He spent decades at sea as a navigator and commander in the Ottoman Navy. He knew currents, coasts, and the consequences of getting them wrong. Later in life, he tried to pull his experience and everyone else's into a single, better picture of the world his empire sailed through. His own notes tell us how he worked. In the margins, Piri writes that he used about 20 earlier maps. 8 came from the old Ptolemaic school. Several were recent Portuguese charts built from voyages along Africa and across the Atlantic. One, he claims, traced back to Christopher Columbus. Another, he hints, was from the time of Alexander. Whether or not that last claim is true, it shows what he thought he was doing. Not inventing shorelines, but combining whatever fragments of knowledge he could find. Only about 1/3 of his world map survives, but it's enough to test his skill. The bulge of West Africa is recognizable. The narrowing Atlantic is reasonable. The outline of northeastern South America, while stretched and rotated, is surprisingly close for 1513. These parts can be compared to modern maps, and they work well enough that historians agree he handled his sources carefully. That makes the strange southern land below them harder to wave away. Drop your gaze under South America on the fragment. Along the base runs another coastline, maybe 4,000 kilometers long in his scale. It bends, hooks, and breaks into bays. Small islands lie just offshore. Little teeth-marked mountains inland. Crucially, it's drawn in the same style as the real coasts above it. To Peary, this southern land was not decoration. It was part of the world a ship might one day reach. Here the argument starts. Some researchers overlay this outline on modern maps and say parts resemble the Antarctic Peninsula and nearby coasts. Shift it, rotate it, and certain bends and inlets seem to echo real features. If that's more than coincidence, it challenges accepted history. It suggests that someone, long before 1513, charted at least the edge of a southern continent that today lies under hundreds of meters of ice. Most professional cartographers and historians are not convinced. In their view, the southern land is simply South America drawn too long and wrapped under the map by the projection Peary used. Early 16th century mapmakers often misjudged positions by hundreds of kilometers. As they tried to squeeze new discoveries into old frameworks, continents warped, coastlines twisted, mountains slid on the page. Seen from that angle, the strange land doesn't fit Antarctica at all. It fits normal mapping error. There are real problems with the ice-free Antarctica idea. When you compare details carefully, many islands and bays on the Peary-Rees map don't line up with any plausible Antarctic shoreline, even if you imagine much less ice. Current models of how Antarctica's ice has changed over the last tens of thousands of years don't support a coastline that matches his drawing. That's why the boldest claims about the map are often quietly dismissed by scholars, even if they rarely make headlines. Still, questions linger. The date, 1513, sits there like a stone on the table. So do Peary's own statements about lost source charts. Knowledge at sea does not always move in clean lines. Information can pass from Arab pilots to Portuguese captains, from Italian chart makers to an Ottoman admiral, copied and miscopied over thousands of kilometers. It's at least possible that some very old fragment of a southern survey slipped into that chain without anyone realizing how strange it really was. Whichever view you prefer, the object itself remains the same. A real map, on real skin, 85 by 60 centimeters, surviving for more than 500 years. Its southern coastline doesn't fit neatly into anyone's story. It might be nothing more than a stretched South America. It might carry a blurred echo of unknown voyages that don't fit the narrative we learn in school. Either way, it sits there under glass, quietly inviting questions. As you picture that dim room and the cracked parchment, you don't have to solve the puzzle tonight. You can let the lines on that little map drift to the back of your mind for now. We move from this fragment to another chart, drawn in 1531, that shows a smooth southern continent nearly 13,000 kilometers wide. When these maps are seen side by side, the mystery doesn't go away. It just settles in a little deeper, like something under ice waiting to be noticed. In 1531, the French cartographer Orontius Phineas drew a southern continent nearly 13,000 kilometers wide, filled with rivers and bays in a place that today is buried under ice. His Terra Australis sits under the known world almost 3 centuries before the first recorded sighting of Antarctica in 1820. This isn't a tiny sketch in the corner. It's a bold, confident landmass drawn as though it really belongs there, at the edge of the map where everyone else was still guessing. Imagine the map unrolled on a desk. At the top, the shapes of Europe, Africa, and Asia look roughly as you'd expect for the early 16th century, distorted but recognizable. Then your eyes drift down. Instead of open ocean at the bottom, you see a continuous southern land stretching from one side of the page to the other. If you convert the scale, that coastline runs for about 13,000 kilometers. In the middle latitudes sit familiar continents. At the base, a seamless world of the unknown. What makes this southern land striking is how smooth the coastline appears. Our modern outline of Antarctica is jagged and broken by ice shelves. Phineas gives us rounded bays, long, gentle curves, and a few large peninsulas. Inland, thin black lines mark rivers flowing toward the sea, and small hill symbols suggest mountain ranges. To a modern viewer, it feels like more than simple decoration. It looks like an attempt to give the far south not just a shape, but a landscape. Why isn't this level of detail taught more openly in history courses? That raises an obvious question. Where did he get this from? Orontius Phineas was a mathematician and geographer in Paris, not a ship's captain. But he worked at a time when reports from Portuguese, Spanish, and French voyages were flooding into Europe. At the same time, he inherited an old idea, going back at least 1,300 years, that a great southern land had to exist to balance the continents in the north. This hypothetical terra australis was almost standard by his day. Mapmakers felt they should draw something there. Phineas went further than most. Instead of shading in a vague blob, he drew a continent with clear outlines, rivers, and mountains. That choice is what turns a standard tradition into a puzzle. Modern radar and gravity surveys now let us see beneath up to 3,000 meters of Antarctic ice. They reveal mountain chains, broad plateaus, and basins cut by long valleys. When enthusiasts overlay parts of the Phineas coastline onto these under-ice maps, they sometimes find curves and inlets that appear to echo real features. Here's where our pattern-hungry brains can mislead us. Give anyone a 13,000-kilometer coastline, let them stretch and rotate it, and they will eventually line up parts of it with almost any real shore. A bay here, a curve there can look persuasive on a diagram but fall apart when you zoom out. Most professional cartographers argue that the matches are small, selective, and overwhelmed by the places where the map clearly disagrees with modern data. For them, the Phineas continent is a clever mix of speculation and tradition, not evidence of forgotten surveys. Yet not everyone is satisfied with that explanation. A smaller group of researchers and writers see Phineas as one piece in a larger pattern that includes maps like Piri Reis before him and Philippe Boich after him. Over roughly 200 years, several European mapmakers drew a detailed terra australis with bays, islands, and rivers. Taken together, these charts don't fit the narrative of total ignorance about the far south. For this group, the Orontius Phineas map opens quiet cracks in the foundation of the standard story, details that challenge accepted history about pre-modern geographical knowledge. Where you land between these views is your choice. What we can say is that, by 1531, at least one serious cartographer treated a southern continent about 13,000 kilometers wide as a real chartable place, even though modern stations there now record winter temperatures below -60 or -70 degrees Celsius. It may be coincidence, or it may be a faint echo of something older. As you picture that smooth coastline along the bottom of the map, you don't have to solve the mystery tonight. You can simply hold the question, how did a 16th century mapmaker with no satellites or airplanes end up drawing a southern world that still sparks debate nearly 500 years later? Now we meet Philippe Boich, who pushed the idea of terra australis even further. He didn't just draw a southern continent, he divided it into two landmasses with a hidden sea between them, an idea that brushes against what modern surveys have found beneath the Antarctic ice cap. For now, let that thought rest like a distant shoreline in fog, something you can drift towards slowly as you settle deeper into this quiet story and let your thoughts slow down. In 1739, a French geographer named Philippe Boich published a map that shows Antarctica split into two main landmasses with a sea running between them, almost 200 years before anyone knew what the Antarctic coastline really looked like. On his map, the bottom of the world isn't empty. It's carved up, organized, and filled with detail in a place where, officially, nobody had been. Imagine that map spread out on a desk by candlelight. Europe, Africa, and the Americas sit in the upper part of the page, drawn in that familiar 18th century style. A bit stretched, a bit off, but clearly recognizable. Then your eyes drift down to the far south. Instead of one big lump of Terra Australis, you see two separate blocks of land. One lies under the Indian Ocean side of the globe, the other under the Pacific and Atlantic. Between them, Buash has drawn an internal sea cutting across the polar region like a hidden channel. Buash himself was not an explorer. He was the geographer of the king, working in Paris, surrounded by reports and charts. His job was to make sense of scattered data. He believed you could reason your way to unseen parts of the Earth. If currents flowed in a certain direction, if depth soundings suddenly changed, then something on the seafloor must be forcing that pattern. His 1739 Antarctic design is what happens when you push that logic into a part of the world no one had actually charted. In Bush's thinking, mountain ranges didn't stop at the shoreline. They continued underwater as long ridges, shaping ocean currents across entire basins. He took a few hundred depth readings spread over millions of square kilometers and tried to connect them into a global picture. The two Antarctic landmasses he drew are partly defined by these imagined underwater chains. The inland sea between them is shown as a kind of secret corridor, carrying water from the Pacific side of the planet through to the Atlantic. Today, we can check that picture in a way Buash could never have imagined. Modern scientists use satellite gravity data, seismic surveys, and ice-penetrating radar to map the bedrock beneath more than 98% of Antarctica. They see deep basins in places more than 2,500 meters below sea level and high ridges buried under thick ice. They've traced long troughs that run from the interior out toward the coast. We now know that East and West Antarctica are quite different regions, separated by complex internal structures rather than one smooth block. So what happens if you compare his map to ours? If you overlay Buach's southern shapes on modern under-ice maps, you can find a few tempting matches. The idea of a split Antarctic with lower regions in the west and higher ground in the east isn't completely wrong in spirit. We also know that Antarctica hides more than 400 subglacial lakes within its basins. When people who know this look back at an 18th century map showing two land masses and an inland sea, it's hard not to feel a little spark of, how did he guess that? But then you zoom in. The neat internal sea on Buach's map doesn't sit on top of one specific real basin. Its outline doesn't follow the genuine bedrock contours revealed by radar. The two landmasses he drew don't match the actual shape of the Antarctic coastline under the ice. When you stop squinting for similarities, the differences are obvious. That's why most professional historians say this is mostly coincidence layered onto a theory-driven map, not evidence of lost high-precision surveys. Still, Buach wasn't just making pretty patterns. For his time, he was taken seriously. He tried to base his designs on data, ship logs, current charts, and depth soundings that sometimes went hundreds of meters down. If 3 or 4 captains in different seas described strange currents or unusual temperature changes, he tried to explain them with a hidden landscape under the water. The southern half of his map is basically a hypothesis drawn in ink, not a record of direct observation. This is where the story gets interesting. On the one hand, we know Buach got many details wrong. On the other, his basic idea that the southern polar region might be broken up by deep basins and channels wasn't completely off. His work doesn't rewrite the history of Antarctic discovery, but it does quietly show that people were thinking about complex polar geography long before steamships and satellites. In a small way, it challenges accepted history by reminding us that the line from ignorance to knowledge was not as clean as textbooks make it seem. You might wonder, why isn't this taught more often? Partly because it's messy and doesn't fit the narrative we like. It's easier to tell a straight story. First, there was nothing on the map, then explorers sailed south, then the outline of Antarctica appeared. Buash's map, and others like it, introduce awkward middle steps, hypotheses, partial guesses, and ideas that sit between myth and science. Those details are often quietly dismissed by scholars as curiosities, interesting, but not essential. And yet, there is a bigger question here that we can't quite shake. Buach's Antarctica might be mostly theory, but it doesn't stand alone. Before him and after him, other European mapmakers also drew detailed southern lands when officially no one had hard data from those latitudes. Maybe they were all just filling in empty space. Or maybe some of them were leaning, even indirectly, on older fragments of information they didn't fully understand. Now we step away from desks and drawings and follow the ships themselves. We'll look at what ancient and medieval sailors could actually do, how far their wooden hulls and simple tools might have carried them into cold southern waters, and how their stories could have filtered into maps like Buche's. For now, if you're listening in the quiet of the night, you can let the image of a split Antarctic continent and its hidden sea slowly fade, like a chart being rolled up, as we drift from theory toward the long memory of the oceans. By the early 1500s, Portuguese sailors had traced more than 40,000 kilometers of coastline, then handed most of that knowledge straight into secret royal archives that Piri Reis openly admitted using. While classroom maps still showed huge blank spaces, a few locked rooms in Lisbon held rolled charts that quietly redrew the edges of Africa, India, and the Americas. To see how that worked, imagine a single voyage. A caravel returns to port after months at sea. Before the pilot ever relaxes, he reports to an official and unrolls a stained sheet of parchment. On it are short notes for maybe 100 or 200 kilometers of new shore. Sandbar here, river mouth here. Fresh water after 2 days' sail, current stronger than expected. He marks where the compass pointed, how many hours the ship moved at roughly 4 or 5 knots, and what the coastline looked like from the deck. On its own, his report is rough, but it joins hundreds of others. Those reports feed into portolan charts, the workhorse maps of the time. On a portolan, the sea is covered with straight lines radiating from compass roses, showing 16 or sometimes 32 fixed directions. A pilot uses them almost like rails. Pick a line, sail along it for 200 or 300 kilometers at an estimated speed, then mark where you think you are. Underneath that simple method is messy data. Distance comes from counting time and guessing speed. Position comes from measuring the height of stars with basic instruments and hoping the sky stays clear. A 10% error in speed over a week can move a reported cape tens of kilometers away from its true location. Now imagine dozens of such pilots mapping different stretches of coast. Back in Lisbon or Seville, a royal cartographer sits at a table covered with partial coasts. A bay from one voyage, a cape from another, an island sketched from memory after a storm. His job is to stitch them into one smooth shoreline. When two segments almost meet but don't quite line up, he rotates one, stretches another, or slides them a little until they seem to fit. Anyone who has forced a puzzle piece into the wrong gap knows how natural that feels. Over a few generations of copying, those tiny adjustments can shift a coastline several hundred kilometers and smooth its jagged features into something much neater than reality. Because maps were treated as weapons, secrecy adds another layer. The Portuguese crown locks its best portolans in a place like the Casa de India. Rival kingdoms guard their own collections. Only a few trusted pilots and officials see the most detailed charts. Independent mapmakers in other countries have to rely on rumors, a smuggled copy, or a single stolen sheet. For them, the world doesn't arrive as a complete picture. It comes as scattered fragments with no clear instructions on how to assemble them. This pattern of hidden knowledge challenges accepted history about information flow in the Renaissance. This is where mysterious southern continents can appear. Imagine you are one of those outside map makers. You've managed to get a fragment of the South American coast, maybe 500 kilometers long, copied from a Portuguese chart. You don't know its correct latitude or how far south it really runs. You also grew up with an old idea that a great southern land must exist to balance the northern continents. To make your world map tidy, you tuck that fragment under the Atlantic, rotate it a little, and attach its free end to that imagined Terra Australis. On your desk, it looks like a real, smooth Antarctic coastline. The next generation copies your work, adds mountains, streamlines bays, and treats that line as fact. Centuries later, someone overlays it on Antarctica and decides it can't be coincidence. In reality, it may just be a clever patchwork that doesn't fit the narrative we prefer about clean, step-by-step discovery. Seen through this lens, many ancient Antarctic coastlines are not ghost traces of a lost high-tech civilization. They're the fingerprints of busy sailors and tired cartographers doing their best with limited tools. And yet the story doesn't end there. Piri Reis tells us he used around 20 different source maps, including secret Portuguese charts. Once you accept how segments can be copied, rotated, and misplaced, most of the mystery shrinks, but not all of it. A few details on a few maps still sit right on the edge of what coincidence can explain. They quietly challenges accepted history and open small cracks in the foundation of the story we've been told. We take those stubborn details and put them beside something very modern. Ice-penetrating radar, satellite gravity surveys, and detailed bedrock models built from aircraft flying thousands of kilometers over Antarctica's hidden interior. For now, if you're listening as you unwind, you can let the image of those old portolan charts slip to the back of your mind. The compass roses, the straight wind lines, the crowded ink along the coasts. We've built a calm, grounded explanation for how strange shapes can appear. Next, we'll see how well it holds when we look under more than a kilometer of ice, and you can drift there with us at whatever pace sleep allows. Today, ice-penetrating radar has mapped over 98% of Antarctica's bedrock, revealing mountain ranges up to 3,000 meters high buried beneath more than a kilometer of ice. For a place most of us imagine as a flat white disk at the bottom of the globe, that is a shock. Under the ice, Antarctica is not empty. It is a full continent with peaks, valleys, and drowned coasts we can now draw with real numbers instead of guesswork. Picture a research plane flying low over the ice sheet. From the outside, it looks ordinary, but inside, it is basically a flying laboratory. Antennas under the wings send sharp pulses of radio energy down through 1,000, 2,000, even 3,000 meters of ice. The echoes from the rock below come back only microseconds later. By flying the same area in a tight grid, the crew can collect thousands of kilometers of hidden profiles in a single season. Each profile is a vertical slice, snow at the top, solid ice below, and then a jagged line where the signal hits bedrock. When scientists stack tens of thousands of these slices together, they get a 3D model of the ground under almost the entire continent. Then they combine it with satellite gravity data, which shows where the crust is thicker or thinner, and with limited seismic surveys. Put all of that together, and the smooth white blob on school maps turns into something much more complicated. In that hidden landscape, some mountain ranges rise about 3,000 meters above their surrounding basins without ever breaking the surface. Other areas sink more than a kilometer below sea level. In a few places, the ice above these low spots reaches 4,000 meters thick. Elsewhere, it thins until rock almost reaches the air. The shape of this buried terrain controls how ice flows, where it melts at the base, and which parts of the ice sheet are vulnerable to future change. Ice cores drill straight through this structure in a few key spots. At some stations, teams have bored more than 3,200 meters down, pulling up long cylinders of ice that record hundreds of thousands of years of snowfall. Tiny bubbles in that ice trap ancient air. Dust and chemicals mark past climates and volcanic eruptions. When these timelines are laid on top of the bedrock maps, scientists can estimate when certain valleys filled with ice, when subglacial lakes formed, and when shorelines must have stood in different places to match sea level changes of 60, 80, even 100 meters. Subglacial lakes are particularly striking. Lake Vostok alone is around 250 kilometers long and up to 1,000 meters deep, sealed under nearly 4,000 meters of ice for perhaps 1,000,000 years. Radar and other methods have revealed hundreds of such lakes across Antarctica, connected by buried channels and old river paths. Together, they form a hidden water network that lets parts of the ice sheet slide more easily, and that also hints at past drainage patterns when climate and sea level were different. Now put this modern picture side by side with the old maps from earlier chapters. On one side, you have radar-based models built from millions of measurements. On the other, hand-drawn coastlines from the 1500s and 1700s based on a few thousand kilometers of ship tracks and a lot of inference. If you overlay them, it is surprisingly easy to find curves and bays that seem to match. That is where some people stop and say this challenges accepted history. Specialists usually go further. They check scale, orientation, and distances. Many apparent matches turn out to be coincidence. A bay on an old chart sits hundreds of kilometers from any real embayment, or a peninsula overlaps deep ocean instead of land. You can often see how copying, rotating, and stretching known coasts could create shapes that only look like Antarctica. This is why the boldest claims about exact matches are often quietly dismissed by scholars once the numbers are checked. Even after that careful work, a few details still sit uncomfortably close to our modern models. Broadly, the idea of a higher, more stable eastern sector and a more fragmented western one does line up. A couple of old maps sketch large southern inlets not far from where we now know major ice shelves float over deep basins. Are these just lucky guesses that don't fit the narrative we prefer, or faint traces of older information folded into Renaissance and Enlightenment cartography? The evidence is not strong enough to prove anything, but it is just strong enough to keep the question alive. As you let that sink in, Antarctica becomes a layered story instead of a blank. On top is the present-day ice we see. Beneath it lies a mapped but unseen world of mountains, basins, lakes, and possible ancient shorelines. And above both, in archives and museums, sit old maps whose coastlines sometimes stray close to that hidden reality. We step away from airplanes and instruments and look at what the ice core timelines tell us about a warmer Antarctica in the recent geological past. For now, if you're listening in the quiet hours, you can just let that idea rest. The continent under the ice is real, complex, and still holding on to secrets that we're only beginning to read. 120,000 years ago, parts of Antarctica may have been up to 5 degrees Celsius warmer than they are today. We know that not from stories or legends, but from cylinders of ice drilled more than 3 kilometers down into the ice sheet. In that relatively brief window of time, the edge of Antarctica may have looked very different from the tall frozen barrier we picture now. Picture a drill camp on the plateau. The wind is low, the horizon is a clean line of white, and a narrow steel tower stands over a small cluster of tents and containers. For weeks or months, a team lowers a hollow drill into the ice and brings up slim cores, each about a meter long. Laid out on tables under bright lamps, they don't look like much, just clear, frozen cylinders. But inside are tiny bubbles of air and layers of dust that record temperature, greenhouse gas levels, and even distant volcanic eruptions. When scientists analyze these cores, a pattern emerges. During the last interglacial period, around 120,000 years ago, global temperatures were a few degrees higher than today, and sea level was roughly 6 to 9 meters higher. That doesn't sound like a huge change when you first hear it, but a 6-meter rise is enough to flood big river deltas, to push shorelines tens of kilometers inland, and to turn many modern coastal cities into shallow bays. The entire outline of the continents shifts. In Antarctica, that extra warmth would have been felt most at the edges. The interior, sitting high and cold, likely stayed buried under kilometers of ice. But around the margins, things could have been different. Ice shelves might have been smaller. Some rocky peninsulas and coastal plains could have been more exposed in summer. Not green fields or forests, this is still a polar environment, but pockets of land and water where today we see only solid ice and drifting pack. Behind all this is the slow machinery of climate. The Earth moves through natural cycles of ice ages and warmer interglacial periods, driven by small changes in our orbit and the tilt and wobble of our axis. Over tens of thousands of years, those shifts change how much sunlight reaches different parts of the planet. Ice sheets grow and shrink. Oceans absorb more or less heat. Sea level rises and falls. Antarctica is not outside this system, it is one of its key players. As ice sheets retreat, sea level goes up. When sea level rises, low-lying parts of Antarctica's continental shelf drown, and only higher ground remains as islands or peninsulas. When sea level falls, those same shallow seas can turn into broad, cold plains that glaciers flow across. Over hundreds of thousands of years, the coastline around Antarctica has probably moved back and forth by tens, and in some places, perhaps hundreds of kilometers. What we see on a modern map is just one frame from a very long sequence. Now lay the human timeline over that. Modern humans, Homo sapiens, have been around for roughly 200,000 to 300,000 years. That means our species was already here during that last warm period 120,000 years ago. We were fewer in number without cities or global trade, but we existed. We were learning to use coasts, follow fish and shellfish, and move along shorelines and islands. When you put those timelines side by side, you get an overlap. Milder Antarctic fringes and early humans on the planet at the same time. Most mainstream researchers stop well short of saying people reached Antarctica back then. There is no solid archaeological evidence for that. No tools, no camps, no clear human traces on the continent from that age. Instead, they focus on what the warm period tells us about how sensitive the ice sheets are and why certain parts of Antarctica are vulnerable today. That is the cautious, data-based view. Still, the overlap doesn't fit the simple narrative that Antarctica has always been completely out of reach. It quietly opens the door to the question, could a few human groups, intentionally or by accident, have gone farther south than we assume, a timeline that doesn't fit the narrative we're usually taught? The same ice core records are also a warning. They show that when average temperatures rose by just 2 to 5 degrees Celsius, sea levels climbed several meters and stayed high for thousands of years. Once big ice sheets start to retreat, they do not stop on human timescales. What happened 120,000 years ago is not only an interesting ancient story, it is a rough guide to what could happen again if similar warming is sustained. If you could stand on one of those old shorelines at the edge of a slightly warmer Antarctica, the scene would still be harsh by everyday standards. The air cold, the wind strong, the weather unstable, but instead of an unbroken wall of ice, you might see rocky headlands, patches of summer meltwater, and stretches of open sea dotted with icebergs. Seabirds would circle overhead, and seals might haul out on bare rock instead of frozen platforms. It is a different mental picture from the static white disk most of us carry. We do have to be honest about how this picture is built. It comes from models, from ice cores drilled down 3,000 meters or more, from seafloor sediments, and from scattered geological clues on land. There are uncertainties in the details, exact shorelines, the size of individual glaciers, the timing of certain advances and retreats. When speculation starts to run too far beyond the evidence, especially when it's used to support dramatic claims about lost worlds, those ideas are rightly quietly dismissed by scholars. But the main conclusions about warmer periods and higher seas are robust. As you let this settle, Antarctica starts to feel less like an unchanging block of ice and more like part of a moving system. Ice comes and goes, coasts advance and retreat. The continent breathes slowly over cycles of tens of thousands of years. In that light, a somewhat warmer fringe 120,000 years ago isn't a wild theory. It's a normal chapter in the planet's long climate story. Now we take that idea off the ice and out onto the water. If the edges of Antarctica were sometimes less hostile than they are today, what might that have meant for the people who learned to cross 2,000 or 3,000 kilometers of open ocean with no modern instruments at all? Could ancient sailors, following currents and stars, have brushed the edge of those changing southern seas? For now, you don't need to answer that. You can just let the thought sit quietly in the background, like a question written in snow, while your mind drifts toward calmer water. Polynesian navigators crossed more than 2,500 kilometers of open ocean using nothing but stars, swells, and the behavior of birds. No compass, no GPS, no written charts, and they still found small islands in a huge stretch of water not once but repeatedly. That single fact should make us pause and rethink what ancient sailors were actually capable of. Picture one of those voyaging canoes at night. The hull is carved wood, held together with fiber ropes. The sail is a simple triangle, catching steady trade winds. There is no engine noise, only the slap of waves and the low voices of the crew. At the stern, the navigator stands or sits quietly, watching the sky. He feels the motion of the hull, notes how the swells are hitting, and glances at the pattern of stars rising and setting. He knows there is an island out there more than 1,000 kilometers away, and he points toward it with confidence. Polynesian wayfinders trained for years to read the ocean. They learned how certain long swells bend around islands 50 or even 100 kilometers before any land is visible. They watched seabirds that rarely fly more than a day from shore and used their dawn and dusk flight paths as living signposts. They memorized star paths where specific stars rise and sink along the horizon, turning the night sky into a mental compass rose. All of this navigation lived in memory, passed down by voice and repetition rather than written manuals. Most people never hear how advanced this really was. Schoolbooks devote pages to European explorers with big ships and metal instruments, then mention Polynesians in a paragraph, if at all. Why isn't this taught with the same weight? Their success quietly challenges accepted history by showing that deep ocean navigation does not require modern tools. It requires a strong tradition, patient training, and the ability to observe the natural world in detail. And this kind of skill wasn't limited to the Pacific. In the Mediterranean, Phoenician traders were sailing beyond familiar coasts more than 3,000 years ago, building networks of ports that stretched across thousands of kilometers. In the Indian Ocean, navigators from East Africa, Arabia, and India ran regular routes well before the age of European empires. They timed their trips around the monsoon winds, which switched direction roughly every 6 months, turning the ocean into a seasonal two-way road. Across these cultures, sailors treated winds and currents as something you could learn, almost like a map painted on moving water. They knew when to depart, which direction to hold, and how long each leg of a voyage usually took. Over time, they built mental charts of entire basins, which areas were safe, in which seasons, where storms tended to form, where fresh water and shelter could be found. That kind of knowledge turns unknown seas into working space. It also creates information that can travel quietly between cultures whenever crews meet, trade, or share a harbor for a few days. Now imagine dropping that level of skill into colder, harsher waters. The Southern Ocean that circles Antarctica is driven by the Antarctic Circumpolar Current, the largest current on Earth. It flows almost unbroken around the continent for more than 20,000 kilometers. Most of the time, it is a brutal place. Huge waves, powerful winds, and dangerous ice. But during slightly warmer phases, sea ice at the margins can retreat a bit, and there may be short windows where conditions, while still tough, are survivable for a capable crew in a sturdy vessel. In one of those windows, it's not hard to imagine a bold group of sailors following a current farther south than planned. They wouldn't set out saying, "Let's find Antarctica." They might be chasing better fishing grounds, tracking unusual bird migrations, or experimenting with a new route between islands. A few days of strong following wind riding on top of a fast current could carry them hundreds of kilometers deeper into the Southern Ocean before they realized how far they had gone. That doesn't prove such a voyage ever happened, but it shows it isn't impossible. We have to be honest about the evidence we actually have. So far, there is no solid archaeological proof that ancient sailors reached Antarctic shores. No confirmed harbors, no ship remains in polar bays, no artifacts from warm climate cultures dug out of old beaches on the Antarctic coast. Because of that, many ideas about very early visits to the far south are quietly dismissed by scholars. That caution is understandable. Evidence should always matter more than a good story. At the same time, the proven skills of ancient mariners don't fit the simple narrative that early people were timid paddlers who hugged the beach. When you place 2,500-kilometer Polynesian crossings next to long Indian Ocean trade routes and the reach of Mediterranean sailors, the old picture starts to wobble. These real voyages are small cracks in the foundation of the idea that open ocean travel was rare or accidental until very recently. Humans have been more ambitious on the water than many of us were taught. So instead of jumping straight to lost Antarctic civilizations, imagine a more modest but still powerful scenario. A skilled crew leaves from a southern island or coastal region during a slightly warmer period, aiming for familiar grounds. They catch a stronger than usual current and steady winds that carry them far beyond their usual range. The air cools, the swell grows heavier, patches of floating ice begin to appear in waters that are normally clear. They may never see solid land, but they know they have reached a different kind of ocean. When they turn back and eventually reach home, whether days or weeks later, they bring stories. Not maps, just reports told around fires or in quiet conversations on the beach. Many days of cold water, heavy swells, more ice, strange birds, and a feeling that something lies farther south out of reach. Over generations, these stories could build into a shared idea of a southern zone, not a detailed coastline, but a mental border where the familiar ocean gives way to a colder, more dangerous belt. Centuries later, fragments of those tales might still be moving around, mixed with newer accounts from later crews who also pushed too far south and then turned back. A scholar or mapmaker, hearing echoes of these reports, adds them to what he knows about winds, currents, and coastlines. When he draws his world map, he gives the far south more shape than the hard data really supports. A curved edge here, an inlet there, maybe a chain of islands protecting a larger land beyond. To him, it feels like cautious reasoning. To us, looking back, some of those drawn shapes don't fit the narrative that nobody had any idea what lay near Antarctica. They look a little too confident. That doesn't mean ancient crews walked on Antarctic rock. But it does suggest that once we accept how strong ancient seafaring really was, it becomes easier to believe that a few small vessels may have been carried far into southern waters, leaving only stories behind. As you sit with that picture, think of a canoe or a simple wooden ship moving steadily under a sky full of stars, guided not by electronics, but by memory and careful observation. If people could cross thousands of kilometers of open ocean that way, it's not hard to imagine their stories traveling even farther, passed from sailor to sailor and port to port. In the next chapter, we'll look at how those memories and fragments of knowledge could have been preserved, distorted, and finally woven into the medieval and Renaissance maps that seem to show more than they should. For now, you can let that thought rest quietly in the background, like a long, gentle swell under the hull, while your mind drifts into calmer water. A single medieval map you might see in a museum could be the end result of dozens of copy cycles, stretching back more than 1,000 years through different hands and empires. By the time it reaches us, the original author is gone, the data is blended from several cultures, and errors sit on top of older errors. Yet that finished map is what we hold up when we argue about who knew a coastline first, or whether someone glimpsed Antarctica long before its official discovery. Picture a small scribe's room in a stone building. A few oil lamps light a wooden table. On one side lies an older chart, cracked and faded. On the other is a clean sheet of parchment. The scribe leans over, copying each bay and headland as carefully as he can. When the ink on the original is too faint, he guesses, a curve becomes a straighter line. Several small islands blend into one. Now, pull back in time. The chart he is copying may itself be a copy of a copy, carried by merchants from one port to another. Before that, there might have been a version in a monastery or city archive. Go far enough back and you might arrive in a royal office or temple storehouse where someone tried to rebuild a lost coastline from a few damaged scraps and old oral reports after a fire destroyed most of the library. This is how geographical information often moves through history, unevenly, with missing pieces and constant risk of loss. Maps wear out. Shipwrecks take charts to the bottom. Invasions and accidents destroy archives. When that happens, people don't start from zero. They rebuild from memory. A pilot recalls a cape and bay from a voyage 20 years earlier. A scholar remembers that an older chart showed islands off a certain coast. Out of these fragments, a new map is drawn, and the copying cycle begins again. In that process, mistakes are not random. They repeat. If one influential mapmaker places a cape a few degrees too far south, that error can spread into dozens of later maps. Scribes copy confidently, thinking they are preserving knowledge when they are really preserving an early misplacement. Over a few centuries, an entire shoreline might quietly slide across the page. Small details are especially fragile. A half-erased inlet might be redrawn as a smooth curve. A narrow strait might be filled in and forgotten. Hill symbols can drift inland or along the coast when they are recopied without clear labels. At the same time, certain core shapes stay surprisingly stable. A distinctive hook of land, a deep gulf, or a tight cluster of islands can survive 10 or 20 copy cycles with only minor distortion. Those enduring features are what make echoes of older surveys possible. Now imagine that somewhere early in this chain, a chartmaker has access to a few genuinely accurate coastal segments from a very old source. Maybe an 800-kilometer stretch here, a 400-kilometer stretch there. He doesn't know their true latitude or how they fit into the globe. He just knows they came from respected surveys. To make his world map complete, he patches these pieces into the edges of known continents or attaches them to a hypothetical southern land that his culture expects to exist. Centuries later, we see those same segments in a medieval or Renaissance map. They're no longer labeled as fragments from an older source. They've been absorbed into a new story. A once correct stretch of coast might now sit too far south or be wrapped around the bottom of the world as part of Terra Australis. When we compare that outline to modern Antarctica or another region, it may feel eerily familiar, but what we are really seeing could be a displaced echo of a different shoreline entirely. This is one reason some old maps seem to show too much knowledge. They don't fit the narrative of clean discovery, where each explorer names a coast and that outline stays fixed forever. Instead, they show hints of land in strange places, bays where no bays should be, or islands that flicker in and out of existence from century to century. Many of these features are quite reasonably quietly dismissed by scholars as errors or duplications, and often they are. But a few details here and there don't fit so neatly. Seen from this angle, echoes of older surveys are less about magic and more about momentum. Once a line finds its way into a respected map, it has a good chance of being recopied many times, even when nobody remembers where it came from. A misplaced cape or bay can enjoy a longer life on parchment than it ever had in the real world. Only when new, direct surveys finally sweep through a region do those inherited features get pushed off the page. As you let that idea settle, the Antarctic-like shapes we saw earlier start to feel different. They may not be proof of hidden empires under the ice. They may instead be artifacts of a very long game of transmission, where a few solid observations traveled through copies, translations, and educated guesses before landing on the charts we still argue about today. That view doesn't erase the mystery, but it does narrow it to something more human and more plausible. We take that narrowed mystery and stretch it again, carefully. If even a few of those original surveys were more advanced than we normally allow, if some small cultures push their navigation or measurement skills further than our standard timeline admits, what would that look like in the record we have left? For now, you can rest with the image of a quiet scribe at his desk, tracing a coastline whose true origin he will never know, while the map in front of him drifts one more step from its source. Modern humans have existed for at least 200,000 years, but the oldest maps we still have are only about 4,000 years old. For more than 190,000 years of our story, whatever people knew about the shape of their world left almost no trace we can hold in our hands today. That gap is huge. It's the space where questions about hidden cartographers and forgotten surveys begin. Picture a timeline stretched out in front of you. At one end, 200,000 years ago, small groups of humans are moving through Africa and beyond, learning coastlines, rivers, and mountain passes the hard way, by walking them. For tens of thousands of years after that, people hug shores, follow fish, cross short straits, and slowly build mental maps of their surroundings. Then, right near the very end of the line, in just the last 2% of that span, we suddenly get clay tablets, ink on papyrus, and parchment maps that survive in temples and libraries. Almost everything earlier has vanished. Why? Partly because of what early maps were made from. A chart scratched into sand, carved into a wooden plank, or drawn with plant dye on bark doesn't last long. A hide rolled up in a canoe might survive a few decades if cared for, then rot away. Even stone carvings weather and break. If a coastal community kept its knowledge in the heads of navigators and only sketched rough guides when teaching, those sketches could disappear within a few generations without leaving a direct trace. Now add rising seas to that picture. At the peak of the last ice age around 20,000 years ago, global sea level was roughly 120 meters lower than it is today. That means many ancient coastlines now lie far offshore, underwater. Any small harbor villages, fish camps, or early seafaring societies that lived on those now drowned shores would have left most of their remains on land that is currently seafloor. We've barely begun to look at those submerged landscapes in detail. This doesn't prove that advanced maritime cultures were there, but it does show why we shouldn't expect to find their maps lying around on modern beaches. It's not hard to imagine small groups pushing their navigation skills further than we usually give them credit for. A culture with a few thousand people living along a productive coastline for 5,000 or 10,000 years has time to learn currents, seasonal winds, and the behavior of birds and fish. They might build sturdy boats, develop star lore to mark directions, and pass that knowledge down in songs and stories. Their charts could be chants, carvings on oars, or scratchings made only during training. If rising seas, storms, or later cultures wiped out their settlements, almost everything material could vanish. What would survive from such a world? Maybe a few durable tools, a handful of ambiguous stone structures, and, if we're lucky, secondhand traces in later traditions. A visiting trader from another region might see a carved board with routes marked on it, memorize the information, and take it home as a story. A scribe centuries later might hear about lands beyond the southern storm belt or 3 days of sea past the cold current and jot that down as a note. Over time, that note could become a sketch, then a line on a world map long after its original context was forgotten. This brings us back to the Antarctic map puzzle. Renaissance and Enlightenment-era mapmakers sometimes drew detailed southern coasts and terra australis outlines that seemed too precise for an age supposedly unaware of Antarctica. Most can be explained as speculation, misread coastlines, or copied errors passed down through generations. But a few features line up just closely enough with real geography to leave small cracks in the foundation of the standard story. One way to bridge that gap without invoking science fiction is to imagine a chain of transmission. Start with a modest but capable survey somewhere in the deep past. A crew charts a few hundred kilometers of cold southern coastline during an unusually favorable climate window. They record distances in days of sailing, directions by wind and stars, and key landmarks as simple profiles. Their tools are wood, fiber, maybe bone and stone, nothing that would survive 10,000 or 50,000 years easily. Their culture declines, moves, or is displaced. The original charts decay, but pieces of the knowledge live on. A remembered sequence of bays, a tale about the land of long ice, a carved symbol for a distinctive cape. These fragments pass into the lore of a neighboring group, then to another, and centuries later they reach the edge of the literate world. A scholar in a temple or palace records them as rumors from distant sailors. Generations later, a mapmaker in the Mediterranean or Middle East reads that dusty text and decides to give that rumor a line on his globe. By the time we see that line on a 16th or 18th century map, it has been recycled, rotated, and merged with other ideas. The original context is gone. The cartographer may believe he is simply extrapolating logically from known coasts and theoretical balancing continents. In reality, a tiny part of his confidence could be resting on a chain of reports stretching back much further than he suspects. This kind of scenario doesn't prove that it happened. It just shows that echoes of older surveys don't require hidden super technologies. They only need time, memory, and a few points of contact between cultures. Most historians are cautious with these ideas, and that caution is healthy. Claims about lost global civilizations are often rightly quietly dismissed by scholars when they jump past what the evidence supports. But if we stay in a narrower, more grounded space, thinking about small maritime cultures, drowned coasts, and knowledge that moves faster than artifacts, we can at least see how the record we have might be incomplete in ways that don't fit the neat narrative we learn in school. As you think about that, our mental picture of the hidden cartographer becomes less dramatic and more human. Not an ancient engineer with satellite-level precision, but a navigator on a wooden vessel, a scribe in a modest archive, a storyteller repeating a route his ancestors once took. Their work may have left only faint marks on the charts we know, but those marks are enough to keep questions alive. In the next part of our journey, we'll let those questions stretch a bit further. We've stayed close to what could be true. Now we'll gently step into what might be fun to imagine. If there were cities under the ice, libraries carved in stone, or deliberate attempts to hide knowledge in symbols and myths, what would that story sound like? And why do those ideas still pull at us? For now, if you're listening in the dark, you don't need to decide what you believe. You can simply rest with the thought that most of human mapping history is missing. And in that long, blank space, mystery has room to breathe. Beneath more than 2 kilometers of ice, Antarctica holds roughly 26.5 million cubic kilometers of frozen water, enough to raise global sea levels by around 60 meters and drown every coastal city on Earth. That alone is staggering. But for some people, the more haunting question isn't how much water is there, it's what else, if anything, might be buried underneath that much ice. For most of this series, we've stayed close to what we can measure: radar echoes, ice cores, satellite data, and maps you can touch. Now we step a little away from that solid ground. We'll look at the more adventurous theories: ancient high-tech civilizations at the pole, stone libraries sealed by sudden ice, and geometric shapes people claim to spot in satellite imagery. None of this is established fact. Think of it as a guided what-if session built on top of the real science we've already covered. Start with the core idea. If parts of Antarctica were milder 120,000 years ago or during other warm periods, could a human culture have settled along its ice-free coasts? In the extreme version of the story, that culture is advanced, capable of building in stone, maybe even of charting the globe. Then, something shifts. Climate cools, ice sheets surge, sea level drops or rises, and the places they lived are overrun by glaciers hundreds or thousands of meters thick. Their cities become foundations for an ice cap that grows above them for tens of thousands of years. Geologists will point out the problems with this. Moving ice is powerful. It grinds mountains down by hundreds of meters over long time spans. A stone building sitting under an active ice stream for 50,000 years would not look like a preserved city. It would look like rubble mixed into ground rock. That's one reason the idea of intact underground metropolises is usually quietly dismissed by scholars. But if we loosen the expectation from skyscrapers under the ice to traces of built structures in more protected pockets, the concept becomes harder to simply wave away. Now picture a subglacial basin, maybe 2,000 meters below sea level, ringed by higher ground. In some scenarios, before the ice expanded, such a basin could have held a deep fjord or inland sea. If people lived on the slopes above that water, carving terraces, walls, or temples, parts of those works might have been sheltered rather than completely pulverized when ice advanced. This is not proof that it happened. It's just a reminder that ice doesn't erase everything equally. Some zones take more damage than others. That's where radar and satellite imagery enter the story. A few enthusiasts spend hours scanning public satellite photos of Antarctica, claiming to see straight lines, right angles, or pyramidal hills that don't look natural. In many cases, glaciologists can explain these features easily: wind-carved snow, bedrock ridges sticking through ice, or simple perspective tricks. But some shapes are ambiguous enough that they float around the internet as quiet hints of something more. They don't fit the narrative of a purely untouched wilderness, even if the most likely explanation is still geology and weather. Add to this the way radar images can play tricks on the eye. When you convert raw echoes into a shaded 3D model of the bedrock, valleys and ridges can line up in patterns that feel artificial at first glance. A series of parallel ridges might look like walls. A steep-sided nunatak can look like a stepped platform from a certain angle. Scientists are aware of these illusions and treat them carefully. People who want there to be hidden cities under the ice tend to be less cautious. Then there are the stone library ideas. The thought that somewhere under hundreds of meters of ice or deep inside a mountain now surrounded by glaciers, There could be chambers filled with carved records from a previous cycle of civilization. This type of story usually stretches far beyond what evidence can support. It challenges accepted history in a way that's more dramatic than justified. But if we pull it back to a gentler idea, say that a few caves or rock shelters holding carvings or objects might one day be found in formerly ice-free zones, it no longer sounds impossible. Improbable, maybe, but not automatically absurd. The sober reality is that we have explored only a small fraction of Antarctica's subglacial world in detail. Radar surveys cover most of the continent in broad strokes, but high-resolution studies focus on a handful of key regions, often tied to modern ice stability and climate questions. Many basins, ridges, and buried valleys are known only as faint shapes in low-resolution data. If someone told you that every square kilometer has been scanned for artificial structures, that would be wrong. There is still room, at least in principle, for surprises. At the same time, it's important not to let that possibility turn into certainty. The lack of clear archaeological evidence, no worked stone recovered from secure subglacial settings, no metal artifacts, no unambiguous patterns in the data, matters. It's why mainstream science does not claim there were Antarctic cities and why such ideas sit out on the edge of speculation. The tension between "we haven't looked everywhere and we haven't found anything" is exactly where these theories live. So how do we use them without getting lost? One way is to treat them as thought experiments that highlight what we do know. Imagining a harbor city now under a kilometer of ice makes you think about how fast ice sheets can grow, how they move, how they reshape land. Wondering if radar shadows could hide walls draws attention to how our instruments work and where their limits are. Even the wilder suggestions create small cracks in the foundation of the simple story that everything important is already discovered. Either way, you don't have to pick a side. You don't have to decide whether you believe in buried cities or only in buried mountains. You can let both possibilities drift side by side. The strictly scientific picture we've built, and the softer, more imaginative one that plays at the edges of it. In the last part of this journey, we'll step back from the details and let Antarctica itself give a kind of closing blessing, a way to hold all these maps, myths, and measurements without needing firm answers. For now, you can relax into the idea that under those 2 kilometers of ice is a real landscape we've only half seen, and that a little mystery, left unresolved, is not a problem to fix, but a quiet place to rest your thoughts. Night after night, Antarctica quietly radiates more than 100 watts of heat per square meter into space. It doesn't flash or flare when it does this. The ice just sits there, cold and silent, while energy slowly leaks away from the planet. At the very bottom of the world, a whole continent glows in the dark in a way our eyes can't see. For a moment, imagine we're looking down from far above the South Pole. Below us is that 14 million square kilometer shield of ice, turning once every 24 hours, wrapped in winds that can circle the continent at more than 300 kilometers per hour. On top, everything looks simple. Snow, cloud, a few scattered research bases. It's hard to believe that under those tens of meters of surface snow are stories that reach back hundreds of years in human memory and millions of years in Earth's history. Over this journey, we've wandered through some of those stories. We started with ancient maps that drew strange southern lands where, officially, nobody had sailed. On a fragment of gazelle skin only 85 by 60 centimeters, Piri Reis sketched a coastline that sparked arguments 5 centuries later. Orontius Phineas stretched a southern continent to almost 13,000 kilometers in width. Whoosh split Antarctica into 2 landmasses, with an internal sea in 1739, long before anyone measured what lay beneath the ice. Some of their lines were good guesses, some were distortions, and some simply don't fit the narrative we were taught about clean, step-by-step discovery. Then we pulled away from ink and parchment and looked at how those maps came to be. Portolan charts built from 40,000 kilometers of logged coastline, secret royal archives. Scribes copying coastlines through dozens of generations, sometimes sliding them by a few degrees, sometimes stitching fragments together in ways that later created the illusion of unknown continents. What seem like cracks in the foundation of history can often be explained by very human habits: tidying the edges of the world, filling in blanks, trusting respected sources even when they were slightly wrong. After that, we dropped beneath the ice with modern tools. Radar planes flying thousands of kilometers over the plateau, satellites reading tiny variations in gravity, ice cores drilled more than 3,200 meters down. Those measurements showed us mountain ranges buried under 3,000 meters of ice, deep basins more than a kilometer below sea level, and subglacial lakes like Vostok stretching for 250 kilometers in the dark. The smooth white cap of Antarctica turned into a real continent in our minds, ridged, carved, and complicated. We followed that thread into time. The ice cores told us that about 120,000 years ago, some parts of Antarctica's edge may have been up to 5 degrees Celsius warmer, while global sea levels stood roughly 6 to 9 meters higher. The coastline shifted by tens of kilometers. Shelves advanced and retreated. In those same millennia, early humans were already on Earth, learning to follow coasts and tides. There is no hard evidence they ever reached Antarctic waters, but the timelines overlapping showed that our frozen mental picture of the South is just one frame in a long cycle. From there, we stepped onto the ocean with ancient sailors. Polynesian navigators crossing more than 2,500 kilometers of open Pacific without metal instruments. Phoenician traders and Indian Ocean pilots building routes thousands of kilometers long by reading stars, swells, and seasonal winds. Once you accept that level of skill, it becomes easier to imagine that in a slightly warmer Southern Ocean, one or two small crews might have been carried hundreds of kilometers farther south than they planned, then turned back and told stories that filtered into later maps. We also looked at the silence in the record. Humans have been around for at least 200,000 years, but our oldest surviving maps are only about 4,000 years old. In between is a long stretch where coastlines may have been remembered in songs, carved into wood or scratched into sand. Rising seas, up to 120 meters higher or lower than today at different times, would have drowned many early harbors and coastal camps. If any small cultures made careful surveys in those drowned zones, most of their tools and structures would be gone. Only echoes might survive. A remembered series of bays, a story of lands beyond the storm belt, a symbol repeated on a later chart by someone who no longer knew its origin. Finally, we let ourselves drift into the more speculative edge of the story, cities beneath the ice, stone libraries sealed by sudden glaciation, geometric patterns in satellite images that might be nothing more than wind-carved snow and bedrock, but that invite what-if questions. Science, so far, doesn't back the idea of grand Antarctic civilizations. The power of moving ice and the lack of clear artifacts argue strongly against it, which is why such claims are usually quietly dismissed by scholars. Yet the idea itself still captures people, not because the evidence is strong, but because so much of the real continent remains out of direct reach. Now, in this last chapter, we don't need to solve any of that. Antarctica can stand as it is, a silent place at the bottom of the world, holding 26.5 million cubic kilometers of frozen water and a landscape we've mapped but barely seen. Its role in this story is almost like that of a patient witness. For centuries, humans have drawn guesses around it, sailed near it, flown over it, and drilled into it. In return, it has given us a clearer picture of climate, of ice, and of our own tendency to tell stories when the data runs out. If you're still awake, You can take a moment to let all those layers settle in your mind. Ancient mapmakers bent over parchment, sailors watching stars from the deck of a small ship, scientists listening to the hum of a radar instrument as it measures ice more than a kilometer thick. A continent changing slowly underneath all of them, indifferent to lines on paper and names in books. As we close, think of Antarctica as a kind of quiet guardian, not in any mystical sense, but simply as a huge, stable presence at the edge of our world. Its snow may be tens of meters deep in places, its ice millions of years old, its winds strong enough to erase footprints in minutes. Yet from your point of view, right now, it can also be something gentle, a reminder that there are still places on Earth that don't demand answers from you. So here is your simple blessing from the silent continent. You don't have to resolve every mystery tonight. You don't have to decide whether old coastlines on brittle maps came from lost surveys or clever guesses. You don't need to picture every mountain under the ice or every sailor who ever watched the southern sky. You can let those questions drift out over the Southern Ocean, moving slowly with the circumpolar winds. Like the bedrock beneath the ice sheet, you are allowed to rest under your own blanket, untouched and unhurried for a while. The maps will still be there tomorrow. The theories will still be waiting. For now, the story stops here, at the bottom of the world, where a continent of ice glows faintly into space and says nothing at all. And that quiet is enough to carry you gently into sleep.